Hello everyone. In this session, we speak about chitosan transforming marine waste into life-saving biomedical solution. Part one, chemistry and extraction. The chemical conservation of chitinous crusting waste into highly pure water-soluble medical-grade chitosan. Shrimp shell as a bioresource, global aquaculture produce millions of tons of shell waste annually. Disposing of this waste represents heavy environment burden. Yeah, these shells are a treasure trove of structure by polymer. Um, crustacean shells are structurally made of 30 to 40% chitin, it tightly bound with calcium carbonate, protein, and the section pigment proposing this biological resource by isolating pure chitin and deacetylating it into medical grade chitosan prevent environmental pollution while driving advanced pharmaceutical sciences. Chemical extraction work through de- um, demineralization, while shell are treated with 1,3 NaCl to dissolve calcium carbonate into soluble calcium chloride, releasing CO2. Deprotonization, minor-free shell are heated with sodium NaNH at 70% to break peptide bond and remove structural peptide decolonization. Crucial for medical application treatment with acetone or ethanol extract, current pigment, the acetylation crude chitin is reflux with 50% NaOH at 100%, scraping acid groups to yield soluble chitosan. Alkaline acetylation kinetics controlling the degree of the acetylation to acquire water solubility in weak acids. It must reach a minimum degree of the acetylation of 70%. Reaction kinetics show the reading the reflux temperature from 80% to 115% dramatically cuts down the required processing time and maximize purity. Biomedical application harnessing citizen unique mechanical and cellular properties to produce clinical grade biomaterials. Monocular and hemostasis. Rapid clothing mechanics. The treated the primary amine group of citizen hold a high positive charge density. This allowed them to bend electrostatically to the negatively charged membranes of red blood cells. This rapid bridging trigger quick aggregation, leading to high integrity physiological cell in the clothing bond. This cascade operates independently of natural clothing factors, which is valuable of patient on blood thinners. Target drug delivery platform, nanoparticle encapsulation, BH responsive release. Citizen undergo easy ionic gelatination when blended with cross-link like tripolyphosphate. This method manufacture biconventional polymeric nanoparticles that seal, dedicate peptide, nucleic acid, and small molecule of oncology drugs, protecting them from aggressive enzyme inside the body. A pH responsive release because citizen protonate at acidic level, the polymer network works well and dissolve under these conditions. This pH sensitivity allowed target therapeutic release in localized acidic biological environment, including hyperacidic gastronizing dune or hypoxic cancerous tissue. Tissue engineering scaffold bioconverted 3D scaffold when lymphocyte free air freeze dried chitosan form highly connected from 3D matrix. So this highly mimic the natural extracellular matrix by blending chitosan with other polymers such as collagen, gelatin, or alginate. Researchers can engineer hybrid composites to scaffold with optimized mechanical strands. This matrix provides critical structure support and physical cues that guide cell attachment, growth, and specialization during cartilage and bone tissue engineering. Broad-spectrum antibacterial action, outer membrane disruption, the polycatonic amine network interact electrostatically with anionic polysaccharide and phospholipids in bacterial cell wall, weakening membrane structure integrity. Cytoplasmic leakage following membrane disruption, essential intracellulose solids such as potassium protein nucleic acid rapidly leak from the cell, leading to immediate bacterial lysis, inhibition of DNA transcription. Molecular weight chitosan can cross the damaged cell wall, entering the cytoplasm where it bind directly to microbial DNA, blocking RNA synthesis. Global chitosan medical marketing segment. So for water handling and the hemostasis, 45% drug delivery, 30% tissue engineering, 15% antimicrobial, 10%. Thank you so much, and waiting for you for the upcoming